Well, here we are with our first example using that elimination method theorem we had talked about in the previous video. We're going to solve this system of two linear equations, linear differential equations. Notice they're both first order differential equations. We'll have x prime equal 4x minus 3y. We'll call that equation 1. Y prime equals 5x minus 4y. We'll call that equation 2. Well, what we do is we move everything to one side, except for, in the equation, the function of t by itself. It has nothing to do with x and y. Turns out there is no such thing, so we end up getting this. We end up getting x prime minus 4x plus 3y equals 0. And for this one, we get minus 5x plus y prime plus 4y equals 0. So we moved everything to the left-hand side and got 0 on the right. So we have homogeneous equations, which makes life a little bit easier. Here's the way we really want to write it. We want to get to this. We want to use the D, the capital D, the differential operator. So what we have is, this is dx minus 4x. So factor the x out, and you get a d minus 4 times x plus 3y, negative 5x. And then this, this is dy. So we get d plus 4 times y, or applied to y, equals 0. That's how we get the x's lined up and the y's lined up, and we can make a matrix out of it. And notice we took the coefficients of the x's and y's, and we put d minus 4, 3, that came from the first equation. And then the second one, we get negative 5, coefficient of the x, and then d plus 4, the coefficient of the y. And the theorem tells us that this determinant applied to x is equal to this determinant. Remember where the zeros came from. This is your f1 of t. This is f1 of t, and that's f2 of t. They're both 0, and they come right here. And when you use it for the y, we get the same determinant here, equals, and now the f1 of t and f2 of t go to the rightmost column. So it's basically this matrix, write it here, but in column 1, replace it with f1 of t and f2 of t. And here you take this matrix, put it here, and you replace the second column with f1 of t and f2 of t. I hope I said that right. Column 1 here, column 2 there. So that's all the theorem gives us. Now we've got to do some solving. Okay, so let's do this one first. Remember, when you have something like a determinant with a 2 by 2, you simply go AD minus BC to get the determinant. So for us, it will be D minus 4, D plus 4, multiply those together, subtract this product, which would be minus a negative 15, which would be plus 15. Applied to x. This is the determinant right here. Okay, and then this determinant is going to be 0. 0 minus 0. So, I need to conserve my space here. D minus 4, D plus 4 gives us D squared minus 16. Plus 15 makes it d squared minus 1. Applied to x equals 0. Well, what are we going to do with this coefficient of the x? We're going to solve this using the characteristic equation that we've seen in the past. D squared minus 1, m squared minus 1 equals 0. Okay, so that means that m is equal to 1. So m squared is equal to 1. So m is equal to plus or minus 1. So we get two distinct roots from this characteristic equation right here. So we already know the solution to x. X of t is c1 e to the t plus c2 e to the negative t. And just as a reminder, this is always the solution when you get two distinct roots. And the plus and minus 1 are the coefficients of the t. Here's the plus 1t and here's the minus 1t. So I'm going to go ahead and circle that, or put a box around it. Now let's proceed with the second one. We're going to get d minus 4. Actually, it's going to be exactly the same, isn't it? D minus 4, d plus 4, minus a negative 15, which is plus 15. Applied to y equals 0. So I don't have to redo that. That's exactly the same thing we had over here. So I know that we get d squared minus 1, characteristic equation. So I know that y of t is equal to, I can't reuse these constants c1 and c2, c3 e to the t plus c4 e to the negative t. And we would be done if we were allowed to have 4 constants or 4 parameters, c1, c2, c3, c4. But we're not. We're only allowed to have 2 because we have 2 first orders. They get 1 apiece. So I just need to figure out what c3 and c4 are. So maybe I'll go ahead and put a box around this, but we still have some work to do. I need another way to write y. And I'm going to go to equation number 1. I'm going to say equation number 1, if I solve that for y, let's see, I'm going to add 3y to both sides to make it positive. So I'm going to get the 3y over here equals negative x prime plus 4x. I'm just rearranging that. So 3y equals negative x prime plus 4x. That's just equation number 1 rearranged. That's all we've done. So let me write that like y equals, I'm actually going to keep I'm going to keep that fraction there. I'm going to keep let me go down here. Y equals 1/3. I'm not going to multiply it through. Not yet, anyways. So now we got to make some heads or tails out of this. Well, what is negative x? Well, for starters, what is x prime? Well, let's go over to x. We already solved for x. X prime is going to be c1 e to the t minus c2 e to the negative t. Minus because we had to multiply this by a negative 1. So I'm going to use that fact. Y equals 1/3 times, instead of negative x prime, I'm going to write negative c1 e to the t plus c2 e to the negative t. Just change these 2 signs. All right, so that I'm underlining is just that. And then I need to add 4x. Well, x is c1 e to the t plus c2 e to the negative t. I need to multiply them both by 4. And we'll be done with this portion. So plus 4c1 e to the t plus 4c2 e to the negative t. So this part is 4x, and this part is negative x prime. And that implies y is equal to, okay, I'm going to do a little bit all in one step here. How about that? I'm going to combine the e to the t terms. I've got negative c1 plus 4c1. That's 3c1 e to the t. 3c1 times 1/3 means we just get c1 e to the t. All right, are we good with that? This and this added up to 3c1 e to the t, but I'm taking 1/3 of it to give it c1 e to the t. And inside the parentheses, I get c2 and 4c2. I get a 5c2 e to the negative t. So I'm going to divide that by 3 for that 1/3. c2 e to the negative t. Now we're done. So I'm just going to go ahead and write this right here. Oh, sorry. Rats, I can't put them quite right next to each other. Y of t is equal to C1 e to the t plus 5/3 e to the negative t. And now we've solved for x, we've solved for y, and we have only two, oops, I left off the C2 here. We have only two constants, two parameters, C1 and C2. So these two are the solutions.